Chef Jacob here. Sorry if I sound a little funny, I'm getting over a cold right now. As you can see in front of you, I have my Tronxy XY2. I am getting ready to complete my direct drive Bondtech modification, running a V6 clone, and I'm going to be doing most of this as a time lapse with a voiceover because I am losing my voice right now. Alright, hope you enjoy what you see. Thanks. So it appears as though I'm going to have to heat it up in order to get this hot end fully apart. Always be very careful when having your hands around the hot parts of the 3D printer. Alright, let's give this a try. We have the hot end apart and it's cooled back down. Make sure before you touch any electronics you always turn off your power. It's a good way to fry your board if you don't. We're going to need the original NEMO 17 stepper motor. I'm going to be putting on a pancake, which you can see is significantly smaller, and as a result is also lighter, which is much better for a direct drive system. However, this is the original motor wire, and it's obviously not going to fit when you mount the motor way over here. So what I'm going to do is, instead of splicing the original, I just have a new 1 meter long motor wire that I'm going to put into this place. For the purpose of getting it operational, I'm not going to worry about wire management right now, but I will tuck it all back inside the casing once I'm all done. So on the original and on the new wire, you can see that the colors are in the same order. It goes black, green, blue, red. Now on the other end, on this one, on the original, it goes red, blue, green, black. And then on the replacement, it goes red, black, blue, green. So you're going to have to swap them on this side, otherwise your motor direction is going to be backwards. If you had a different open source firmware, you could just swap it in the firmware, but these Tronxy printers are closed source, so it's much easier just to swap the pin directionality. Alright, so I'm going to get started on that, and then we'll get back at Now, as you can see, I just finished swapping them out. Just simple flathead screwdriver, or you could use a pick and the little prongs, and then I now have black, black, or green, green, blue, blue, and red, red. So now they match. So now the motor should spin the right direction when we turn it on. I decided to go ahead and just run the wire through the cable management right now, because it's easy enough just to take the two ends, wrap them together with a little bit of electrical tape. You can probably use a zip tie, and then you just snake it right through, and then you don't have to worry about going back later and trying to figure out how to get it all the way through all this tubing when you can just do it in the first place. Better do it right.
Going in and out of love. it with no reverse. I know that we need it, know that you feel it. I gotta know, I gotta know. Forever repeating, love keeps on leaking. I gotta know, I gotta know. Oh, 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 oh. I know, oh, 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 oh. This thing is in my head. I can't make you understand. Oh, 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 oh. I gotta shut it off. I gotta shut it off. Baby, we go back and forth. I gotta know, I gotta know. Had enough and I want more. I gotta know, I gotta know. Oh, 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 oh. I know, oh, 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 oh. This thing is in my head. I can't make you understand. Oh, 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 oh. I know, oh, 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 oh. This thing is in my head. I can't make you understand. Oh, 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 oh. I gotta shut it off. Oh, 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 oh. I gotta shut it off. I gotta shut it off.
Alright guys, so we all know mistakes happen and nothing is perfect. So I made a small design flaw. You can see I got the first two screws in no problem, and it's pretty securely mounted. But I don't want to rely on just two screws. And I made the slots go all the way across. I just forgot to design the hole in this front plate to where you can get the screws through it, and the angle is too steep for me to get these little screws on without them falling off of the Allen key. So I'm going to use trusty old Black & Decker to modify this piece slightly. In the future I will redesign it and remount it. It's just for now to get the functionality working. Alright. Alright guys, now anytime you use a drill on your printer and you're going to end up with a little bit of debris, it's always good practice to use compressed air or a vacuum just to make sure you remove all the little bits and particles so they don't get inside your electronics. So we're going to go ahead and do that now. Well, it wasn't that satisfying. Alright, good to go. Alrighty guys, I noticed another small problem with my design. Again, something that will be easy enough to fix going forward. It looks like I'm going to have to offset the extruder another probably 30 degrees because we're losing about 30 degrees on the X build volume. If you go all the way to the left, it again goes about 30 degrees to the left, which is completely fine. It's just that we're going to be losing a little bit. So we're going to want to modify this bracket, and then I'll put it on once it's done. Alright, now that everything's been tested, everything works, it's all plumbed up, we're going to go ahead and get the part cooling fan mounted. It goes right up here. Gotta move the wires a little bit, and it screws right into the bottom. I designed the mount to where the threads would go right in, so you don't have to worry about putting nuts on the other side. In the future, I might put captive nuts, but for now, this seems to be more than adequate. Alright, let's get started on that. Okay, now we got the fan duct mounted. We're going to have to go ahead and mount the original part cooling fan. This actually is not the original one that came on the printer. I decided that I couldn't find any cooling shrouds that I liked, so I found one that fit for an Ender 3 that I slightly modified that used these radial 50-15 fans. So this is the one that I used previously. I'm just going to repurpose it. I did add a quick connect to it, so we're just going to go ahead and get this installed. After that, all that's going to be left is to button up all the wire management, re-level, adjust the Z offset switch, because this is going to be about 20 mils lower, and then we should be good to start testing. Alright guys, you'll notice here, the new cooling fan, for the Hotend cooling fan, it has a significantly shorter wire than the original. So what we're going to have to do is splice in. I already cut the end off the other one where we're going to splice it into. So we're just going to splice into the original wire, red to red, black to black. And I have some 22 gauge silicone wire, and we're just going to solder it in. And then I have my heat shrink tubes. We're going to make it a good solid connection that should last for the rest of the life of the printer. Alright, let's get started. Okay guys, this is going to be my one exemption to the rule of not having your printer powered on while you're working on the electronics. I'm just going to use my digital voltmeter to ensure that the red is red and the black is black are positive and negative as they should be, verify the polarity. So I just snipped a little bit off the end of each one. I'm going to put black to black, red to red. Alright, getting no polarity, no current, so we're going to go into the tool, fan, we're going to turn the fans on just to verify. Black to black, red to red, and we're getting the correct polarity, 12.05 volts. So, perfect. Now we know that red is indeed positive, and black is the ground or common. Alright, now we're going to get started with the splicing.
Can't for my wins, I need my ends. This life is real, and play pretend. Came off the bench, I get it in, I get it in, I get it in. Can't for my wins, I need my ends. This life is real, can't play pretend. Came off the bench, I get it in, I get it in, I get it in. I'm on my job, I get it done, but you should know that. Shine like a sun, a 101, you should know that. I get the front and in the back, you should know that. No need to stun, it's never cap, you should know that. All I know, 10 toes, never fold, bang roll, on the go, ice wall, ice wall, ice wall. Came for my wins, I need my ends. This life is real, and play pretend. Came off the bench, I get it in, I get it in, I get it in. Came for my wins, I need my ends. This life is real, and play pretend. Came off the bench, I get it in, I get it in, I get it in. I miss my baby, so I hit them on the FaceTime. I need it all for them, so no, I cannot waste time. Facing these oceans, feel the water on my waistline. We trust the process and I only know it takes time. You can get it, got no worries, I'm gon' make mine. Going global, I'ma get it out the state lines. Paying taxes at a more than what you make now. Different bracket, eating off a different plate now. For my wins, I need my ends. This life is real, and play pretend. Came off the bench, I get it in, I get it in, I get it in. And for my wins, I need my ends. This life is real, can't play pretend. Came off the bench, I get it in, I get it in, I get it in.
Alright, now a quick test to make sure that that solder job worked. It's all heat shrink and it's soldered all together. We'll worry about management of the wires later. Just turn it on and we'll see what the fan does. And it spins. Alright, time to move on. Okay, so I want to be honest with you guys. Anytime anything goes wrong, I'm going to show you. Because not everything's perfect. And as a chef, that's like the first thing you learn. You have to do it again and do it again until you get it there. But first time off, nothing's ever perfect. So I just had to switch over and put my original NEMA 17 stepper motor back on. This is again temporary because my pancake motor that I ordered is actually bad. I turned it on and it clicked a couple times and that was all it would do. I know it's not my wiring because as soon as I plugged it back into the original motor, it functioned perfectly. Again, my steps per millimeter are wrong, but as of right now, it's turning the right direction. And then once I go in and adjust the firmware, the extruder should be working perfectly. I'm going to go ahead and return this and get a replacement, and then I'll swap it back when that happens. But just so I can complete the video and show you guys my upgrade, for the sake of getting it done, I put on the original motor again. Alright. Alright, the wire management is pretty good. I'm not going to tighten up everything just because I know I have to redesign this mount a little bit. So for now, I'm just getting it to where it's safe. It's not going to be a fire hazard and it won't get in the way of the prints while it's working in the meantime. Because I'm probably going to end up using this printer to print the parts for this printer. So now what we're going to do is we're going to just do a quick, I'm not even going to heat it up, just a cold level so we can readjust the Z end stop. And then after that we'll heat it up and do an actual level, and then we should be pretty good to start printing. Just real quick, there's the spot in the top of the Bondtech extruder where you can put in the Bowden tube. Like on a Reprusa, it has just a short, probably 75mm tube. What I like to do is called a reverse Bowden. That way it tracks it all the way, especially since I'm going to keep the original placement and use the original filament runout detector. So what I'm going to do is I'm going to have this in here, and I'm going to end up printing a little mount that holds the end of the tube right here. That way it'll still feed, it has the full range of motion as if it did before, and the filament will glide just as well as when it was a Bowden. But we have the benefits of having a direct drive. The reason I like to do this is mainly to help make sure that the filament makes it from the spool or from the detector to the extruder without bunching up. Sometimes when it gets towards the end of the spool, filament tends to curl up a lot. And so what we're going to do is have this, and it'll guarantee that it stays straight and goes directly into the extruder all the time. Alright, so let's get started on it. Alright, we got a pretty good rough level in. The offset is pretty close. So I'm just going to go ahead, foam all. Alright, everything seems to be working fine. So the next step is going to be the hot level, where we're going to heat it up, use the sheet of paper, and adjust each of the four corners to get it as close as we can to being 0.2 millimeters. And then after that we're going to have to go into prompter phase and send the G-code commands to change the E steps per millimeter for the extruder. On my other computer I have the Bondtech set up, and it is at 405 millimeters per second per step, steps per minute. And so we're going to have to start somewhere around there and adjust to make sure that we get the extrusion right on this new direct drive system. Alright, so now I have the bed level, I have the extruder switched out, everything heats up, all the fans work, and we're pretty much ready to go other than adjusting those settings in the firmware. For right now, until I print a piece to work, I'm just going to use a couple zip ties, and I'm going to zip tie the old fitting with the Bowden tube right here in the original holes that were there. That way it can feed right out, go right in. Like I said, eventually I will design and print a 3D printed mount, and then I will update it at that point, and I will let you guys know what it looks like. However, I don't know if you'll be able to see it in the camera, but inside of this tube got burnt a little bit from the old setup, and there's a little piece of white filament stuck in the center. So I'm going to use my Capricorn Bowden tube cutter, and we're just going to cut off a little at a time, because we want to keep as much as we can until we see that it's no longer blocked. It's right there, it's still blocked. Just a little more. And there we go. So now it's a nice, clean, open piece of Capricorn tubing. And when I zip tie right here, filament will be able to feed right in and go ahead. Alright, it's not pretty, but it'll work. Just go ahead, take the snips, cut the excess zip tie off, and until I get the 3D printed version, that'll work. It'll hold the filament tube in place. Filament can go into the sensor, directly into the Bowden tube, and it'll be fed right down to my direct drive extruder. Alright, time to get on to the firmware changes. Alright, so I tried to hook it up to my computer through Interface. I'm not entirely sure what's wrong. I've never actually used this printer on my computer, but when I plugged it into the USB cable, it started to get hot, and it would go into the safety shutoff. So I'm not entirely sure. I tried 2 different USB cables, and I tried all 3 different USB ports on my computer, so I'm not entirely sure, but obviously there's something wrong with the printer side. But other than that, it always works, so we're going to roll forward. What I ended up doing was writing a G-code, which I'll show you in a second, on a micro SD card. I just used Notepad++, wrote the G-code script, saved it, added it to the SD card, which we're now going to insert into the printer. If I can get it in there, right? We're going to go to print, and we're going to run this G-code just like any other print file. So just scroll down, and you'll see right there it says Bondtech G-code. This is what I labeled it as, Mark 1. We might need to make adjustments to get the extrusion right, but this is what I found online from another community for these printers. So I decided to just give their numbers a try, and we'll adjust from there. So you just click on the file and go to play. And that's it. Just takes a second, saves it on there. And now if we go to Tool, Movement, and I'm going to extrude 10 millimeters, you're going to be able to see the gear, right? There, focus, is going to move much faster than it used to. So now that should be very close to where it needs to be to properly extrude with this setup.